Hi everyone, so in this video we will see quite an advanced topic. We saw together how to pattern on insulating substrates with pulse heating and with temperature maps. If we want to pattern also in grayscale, that's an option. We also have videos regarding high resolution patterning strategies and high resolution patterning on high resolution stack that you can watch, and I recommend you to watch before watching this video. Now we will see together how we can try to pattern in high resolution on insulating substrates, so using the thermal bending effect. In this case, you may already have seen this if you've watched the videos of patterning in high resolution. This is a design that we can import if we want to pattern in high resolution or test high resolution pattern. So this is also in your geometries in the nanometers package folder. You can find these lines in high resolution. Which kind of modifications did I do on this specific design? Well, I put into D and increased the scaling across the X because my pixels were changed to 5 into dx and 5 in dy and 25 in dy. 25 is what sets the spacing between the lines. So we have a half pitch of 25 nanometers, which is basically what we say is the highest resolution within the specs of the nanofiber tool. Even though, as we've mentioned already in previous videos, we can try to push the patterning resolution even further. I will say 20 nanometers half pitch and 15 nanometers of pitch could be achieved with experience and mastery on the patterning parameters. In this specific case, I wanted to have a quite high density along the X direction for pixels. And since we are patterning on insulating substrates, or we assume we're patterning on insulating substrates, the depth here that we set doesn't really do much because we don't apply any force. So this is the design, the geometry that I import. We have already quite some geometry, so we see that it's a number 14, the one that I just imported. And so we can go and select this design and place it here. Very well. So finding the parameters that are necessary to pattern in high resolution on, so with a thermal bending effect is quite challenging, so it requires some optimization. I can show you some parameters that I'm using at the moment that can be maybe a good starting value for you. But as you may have seen also in other videos, there is not just one set of working parameters. What's important when you use the nanofiber is that you know that you can obtain the same pattern with different parameters. This is, I would say, my recommended started set of parameters, or the parameters that work in this moment with this specific cantilever. But from cantilever to cantilever should not change drastically. So what do we have here? We see that the force is disabled, so we are not using any force in this case to pattern our high resolution lines. I put the forward height quite low, 200 nanometers, and the writer temperature is at 1200 Celsius. And I'm using a pulsed heating mode. So we can check here that I have enabled pulse heating. And I also put a heat pulse of 30 microseconds. Pixel time is adjusted accordingly to 40 microseconds. So this is the values that I would like to use to try patterning on these insulating substrates without using any force. I also put an upsampling factor of 4 in order to have a better reading of my pattern, because if we use 25 nanometers pixel size with a sampling factor of 2, then we will not see well the separation between the lines. So let's try to run this pattern. This was a result of a previous test that I did. I would say the approach that you should adopt is the similar approach that you will adopt by writing with pulse heating mode. So you should find a set of values that allow you to first write onto the substrate and then tune them in order to have your desired depth. So in this case, we can see that we're writing quite nicely. This is a 25 nanometers half pitch. We have a little bit of pileups that you can see. But so far, I would say we can see that these lines are well separated, and they are all at least 4 nanometers deep, which is what we say is the minimum depth pretty much required if you want to have a successful transfer. So we can see that we have a nice set of high resolution lines. So indeed, it's possible to pattern in high resolution on insulating substrates with thermal bending. I would say pushing the resolution further is even more challenging than pushing the resolution further with the use of force. So it really requires quite some experience. My recommendation to you is try to start with similar set of parameters, use the pulse heating mode, try to play with the heat pulse and with forward height and the writer temperature to achieve a good balance between these parameters in order to successfully pattern these designs on your substrate. Of course, another recommendation that I will give you is try to first pattern in high resolution, but maybe not so high resolution. Maybe try first 40 nanometers half pitch, 50 nanometers half pitch, progress, and by progressive increase of resolution, then you should be also more successful, and will give you the results will hopefully be easier to will be more easily obtained. We can also maybe quickly see what happens if we change some values. I mean, the situation is similar to what we have seen in the previous videos, but just to make sure that everything works as expected, let's say what may happen if I increase the temperature. Well, I expect to write a little bit deeper. Maybe there may be some merging of the lines. Let's try to see what happens if I put 1300 Celsius. In this case, the heat pulses are going to reach a higher temperature. We should be able to reach a higher temperature on the interface between the tip and the substrate. Therefore, we will probably write deeper. Here we may have merging of the features. We're also using a high resolution stack in this specific case. So we see that we don't write much deeper. Actually, it seems like we're writing, maybe some lines are a little bit nicer, but we start seeing some merging of the features here. So this is pretty much as expected. We can further try to optimize this pattern, but I will say it looks already quite good. It was probably slightly better for transfer process in the example shown before, but yeah, I hope this video that I want to try to keep short can help you to pattern successfully on insulating substrates in high resolution using the thermal bending effect. So advanced features for I hope advanced users, and I hope that this can help you with your research.